Okay, so today we look at 4.2, linear relations. We're going to continue on with linear relations. In this chapter 4, we're setting the foundation for understanding graphs, functions, relations, equations. We're getting to know all sorts of types of definitions of things. We already talked about independent and dependent variable. In your textbook, they describe that as well in this section. We talked about it in 4.1 already. But we're going to talk about the quadrants of the Cartesian plane or the Cartesian coordinate system. And you guys have lots of experience with this already, but we're going to go over some important details so that we're all understanding this, okay? So once again, everyone should have their notes out and be following along with this, please. Try not to work on anything else while we do this so that you can make sure you pick up everything. And if you don't have the notes with you, MrMathWell.com, go print them out. All right. The graph, now I don't have too many blanks in this section, so what I want you to do is highlight things or underline things, okay? So I didn't get too many blanks on this section for you to fill out, but just highlight some of the things that I point out. So notes, the graph we use to plot the points is called the Cartesian coordinate system. I will also call it the Cartesian plane. That is also a very common name for it, so the Cartesian plane. And that is the XY lines, or XY axes. The X-axis, which is the horizontal, goes from left to right this way, and labeled X. The Y-axis is the vertical, up and down. So if we're highlighting things, Cartesian, still on freeze. I see that hand, thank you. The X-axis is the horizontal axis. The Y-axis is the vertical axis. Okay, very important. And of course, horizontal goes sideways, left and right. You look out across the skyline there. We're on the 4th floor, so we can see the skyline. And if you see where you can't see any buildings there, you can see the horizon, and it goes sideways, left, right. That's the horizon, okay, this way. The y-axis is vertical, okay, up and down, vertical. The origin, this is another important point on the Cartesian plane, and that's the intersection of the two axes. That is the point where they meet, and the coordinates of the origin are, surprise, surprise, 0, 0. The origin is 0, 0. Now, again, you guys should have lots of experience with plotting points on a Cartesian plane, or plotting points, and we're going to go over that again really quickly. But the origin is the coordinate, has the coordinate 0, 0. And I'll explain a little bit more what that means later. And every time I write 0, 0, I really, all I see is a face. I see two eyes, a nose, and like, I just kind of want to, finish the face here, and this guy's got something wrong with his orbital bones there, more like a skeleton, but that's what I see, so I apologize if you see that now forevermore. But actually, that would be a pretty good skeleton. Let me see if I can make the skeleton here, so I'm not sure how a skeleton actually goes. Kind of like, there we go, hey, look at that, come on. That's actually pretty good, hey? It looks like a robot, yeah, okay. Anyways, that's what 0, 0 does to my brain. It kind of goes like that. 0, 0, the origin. Yeah, see, that's all I can see. There's some smiley. Okay, anyway, my bad. We're distracted now, okay. So did you know that in the Cartesian plane, when you put two lines together like this, it makes 4 quadrants. So each section, these are important, but they're called quadrants. Quad is the root word for 4, right? 4. Hey, guys, got your notes out? Hey, notes out? Following along? Got your notes out? All right, no. Let's go. Wow, you're 5 minutes behind already. Come on. 4 quadrants. Now, the first quadrant is here, and again, I will explain why this is the first quadrant in a few minutes, but this is the first quadrant. We always start in the upper right, and then we go counterclockwise. The second one is over here. Counterclockwise, there's the third quadrant. Counterclockwise again, the fourth quadrant. Okay, so when we're describing points on a Cartesian plane, you might hear me say, it's in the third quadrant. It's a third quadrant coordinate, third quadrant point. And then you know that it's kind of over here somewhere, down here, all right? So those are the quadrants. A point consists of 2 coordinates. Okay, now there's going to have to be some adjustment on your notes. There was some typos here, so you'll have to look carefully and change some words when we get through here. I will highlight that as we go. But a point consists of 2 coordinates, the x coordinate and the y coordinate. And pretty amazing that the horizontal axis is labeled the x-axis and the vertical is labeled the y. So that gives you a strong indication of the directions that these numbers or values will actually give you information about. So the x value is the value that you go left or right in the horizontal direction. So if you have a negative x value, that means you move from the origin, and again, this is always from the origin, you move left. So negative x, you move left. Super important. So we always start at the origin, always start here, and if I have a negative x value, that means I have to move left, however many units that number is. If it's positive, then I go the other direction and I move to the right. Okay, so a positive x moves right. And again, this is how we find a point or place a point on the Cartesian plane. We have to obey the coordinates there. Now, this is where you're going to have to make some adjustments. It's a bit of typo here. This should say negative y value moves down. So negative y moves down. And a positive y moves up. So please make changes there. I think there's some typos there. You have to change some words. Make sure you have this right here. All right, the x value always goes first. So if you see a coordinate, like this, 5, negative 2, okay, that's a coordinate for a point, or coordinates for a point. This is always the x values. This is always the horizontal direction, okay? This is always the horizontal direction. This is always the vertical direction, x, y. Very important. And remember, each point consists of two numbers, which are the directions that you will move to get to the point. And that is always from the origin, the directions to get you to one point. And I'm going to add this, and you should add this too, please, from origin. So from 0, 0. You always start there, and then you move accordingly, whatever the numbers tell you. So this point right here, if I was to just sketch this real quick, so there's a y, there's the x-axis, then I would go from the origin, I would go 5 units to the, it's positive, so I move it to the right. 1, 2, 3, 4, 5. So that's 5 units. I don't put a point on there yet because I have to complete the directions here to get to the point. Now I go negative 2 on the y, says I go which way, up or down? Down, good. And how many units? 2. So I'm going to go 1, 2 units down, and there's my point right there. That is 5, negative 2. Okay? Now, what quadrant is this point in? Fourth. Good. Okay, some of you are paying attention. Fourth quadrant down here, you see? Fourth quadrant. Okay. Any questions about the first page there so far? All right. Would you say that you know all this already? Anybody say you know all this already? Kind of like, yeah, kind of knew all this. Okay, that's fine. That's fair. That's good. It's good to review though, isn't it? So we're all on the same page. Okay. So let's get some practice here. Let's plot the following points on the coordinate grid below. All right. Oh, look at that first one. That's like almost the exact same. Sorry, I'm just going to make this a little bit bigger. Just going to stretch this out a bit. All right. Cool. Okay, plot the points on the grid. All right. So, so correct me if I'm wrong here. Negative 2, 5. What I do is I put a point at negative 2, and then I put a point at 5, right? Yeah. Oh, I kind of fooled some of you there. No, it's the directions. Okay, so I start where? I start at the origin. That's where I kind of start, and I don't place any points yet, but I would start here, and I'm going to go 2 units to the what? Left. And so what you can do is kind of sketch, hey, there's a jump of 1, there's a jump of 2. So I have to go 2 units to the left. Now we're going to erase these little jumps later, but this is a good way to show it. And then positive 5 in the y, for the y value means to go which direction? Do I go right? Do I go right again because it's positive? No. Which way do I go? Up. Very good. Okay, the second coordinate's always up. So I go 1, 2, 3, 4, 5. See that? 5 units up. So guess what? This is where I put my point. And of course, the jumps there, you should either do that lightly and erase, or just kind of like, just kind of like with your pencil, just kind of count. But you don't want to leave those little jumps on there, really. So that's the point. And then let's label the point. So let's go negative 2, 5, right near that point. And that is my coordinate, negative 2, 5. Excellent. Very, very good, you guys. Okay, 2, 3. 2, 3. Both these are positive, so I start from the origin, and I'm going to go 2 units to the, shout it out, right or left? Right. That's correct. And 3 units up. There you go. That is the coordinate 2, comma 3. All right. I'm sure some of you have maybe gone ahead of me already. That's great. Let's do the rest of them together. 5, negative 3. So I'm going to have to go 5 units to the right from the origin, 5 units to the right, and then 3 down. There's the point right there. That is positive 5, negative 3, quadrant 4. Awesome. 0, 3. Uh-oh. Boy, we haven't talked about what happens if one of the coordinates 0. What does that mean? Anybody want to tell me what this x value of 0 would mean for us? Anybody want to shout it out? You stay on the axis, whichever one it is.
Yeah, so
keep going.
It's the x-axis.
Yep.
You would stay on that line, and it would just stay in the middle, and you would just go up.
Okay. So if it's on the x, you're right. We got to it. If it's on the x, you don't move left or right. You move 0 units. From the origin, you move 0 units. So you just stay right there for that first coordinate. You don't move either left or right. And then the second coordinate is the y-coordinate. So now I'm going to go up 3. So this is a point that's on the y-axis. So this point right here is on the y-axis because we've moved 0 units in the x direction from the origin. Very good. Okay. 0, 3. And in math, these are called intercepts. This is a y-intercept. And anything that's on the x-axis, any point that's on the x-axis, like, oh, I don't know, like maybe this one, F, okay? That one is on the x-axis because we go 6 units to the left, and then I go 0 units up or down. So guess what? I just plotted there. And that is an x-intercept, okay? All right. We'll maybe talk about intercepts a little bit later, but hey, intercepts are a huge part of math. As you move through high school and university, y-intercepts, x-intercepts, huge. Okay, very, very important. Okay. Oh, there's one we didn't hit here. This is negative 6, 0. Negative 5, negative 4. Okay, what quadrant is this going to be in? What quadrant is that going to be in? We have to go left and then down. I heard it. 3rd quadrant. Very good. Very good. Left. What was it again? Negative 5, negative 4. So I'm going to go negative 5 units, 5 units to the left. Then I'm going to go 4 units down. Boom. Right there. Negative 5, negative 4. That is excellent. Okay, does anybody have any questions about that? Or does that seem confusing to anyone? Is that confusing? Okay, hopefully that's okay. Now, when the points have a letter attached to them, in the future, you're probably going to be able to put the letter beside the point. But I wanted to put the coordinates there so that we could actually, I want to highlight, and I don't know if this is coming later in the lesson actually, but I want to highlight a couple things. What do you notice about all the points? And really, there's only one point that's in quadrant 1. This is called a quadrantal point. Like it's on the axis, so it's an intercept. It's quadrant. We don't really think about those ones for this, but this is my quadrant 1 point. This is my quadrant 2 point. This is my quadrant 3 point, and this is my quadrant 4 point. So, is there any description that you can give me? Like, all points in quadrant 1 will look like this, or will be like this. Any guesses? Any guesses at all? Yeah?
They're all positives.
Okay, every coordinate, all the x and y values will always be positive. That is absolutely correct. That's perfect. Because if I go to any point like this one is positive 5, positive 6. This one is positive 6, positive 3. They're all positive, positive. So I'm going to get you to do this. I'm going to get you to write here all the coordinates like this. Positive, positive. Positive, positive. Yeah. And seeing as we're talking about the origin point, the face, this one looks like a face that's been knocked out. That's what that makes me think of. Like, you know, the guy's like, birds flying, you know, knocked out. What about over here? What about the points in quadrant 2? What could we say about all the signs on those points? What do we have? We have X is negative, Y is positive. That is absolutely true. Okay, and this face is like winking at us or something. Half knocked out. Negative, positive. Yeah, all the points will have the negative X coordinate, negative, and then positive Y coordinate. Good. And this one? Negative, negative. Okay, this person's sleeping. Definitely having a doze here. Having a doze. And what about this one? Positive, negative. Very good. Okay. That's totally true. That's totally true. So that's something that's going to maybe come in handy too. All right. Any questions there? All right. Remember, math is about recognizing patterns and using those patterns. Yes?
For D, I think it's 0 and 3. Is 0
Yeah.
like you don't include that?
Well, zero technically is not negative or positive. That's why it kind of doesn't really fit. Like, is 0 negative or positive? I don't know. Like, do you go forward or back when you go 0 units?
So you just
Do you go left or right, up, down? What do you do? So that one, this one here, I mean, we're not going to worry. I just didn't highlight these as far as drawing conclusions about the pattern here. But I'm not sure exactly what your question is. Like, what is your actual question? Which quadrant is it in? Is that what you're asking?
No, like,
Because it's in kind of neither.
never mind. It's fine.
Okay. Okay. If it comes up again, that thought, please ask me later. I just didn't quite catch what you were wanting to say there, but that's okay. All right. So let's say we can create graphs for many different things, as we've talked about yesterday, like hours worked and amount earned, distance traveled over time, figure number and number of squares. So I don't know if, did you guys run across this in your homework yet? The figure number 1 has this many squares. Figure number 2 has this many squares. What's the pattern? You guys come across that question yet? Okay, some of you have. Okay, we'll talk about that later if anybody has any trouble with that. But yeah, we can graph all sorts of things. And some of these things don't have any negatives. So some of these things, we only focus on quadrant 1. That's the most popular quadrant. Because if you think about it, if you're going to graph the points that connect the hours that you work at your job and the money you earn, you're never going to be able to work a negative number of hours, right? You work 0 hours or you work a positive number of hours. So there is no value for negative in lots of real life situations. The amount of money that you earn, okay? Now there is maybe an argument to say if you miss work one day, you're kind of like working a negative number of hours and maybe the boss won't pay you. So that's kind of like negative hours and negative pay. But for most real life situations, we use the first quadrant only. Lots of real life situations, we can use multiple quadrants. But anyways, we'll get to that as we go. Okay, when we create a graph, remember these important things, okay? When you're labeling the axes, now this is called scale, okay? When you're determining the scale for the numbers on the axes, increase by the same amount on each axis, okay? The important thing is they're the same amount on each axis. So that means for each square or each regular distance that you write, it has to be the same amount. So if your first square is 1, then all the rest of the squares have to be 1 as well. So you can't go 1, 7, 9, 55, 56, on each square. You can't do that. You have to make it evenly spaced, okay? So you could increase by 1. You could increase by 10 or 12 or 15. On each axis has to be the same. Now this is saying that on the x-axis you could increase by a certain common amount, and on the y-axis it could be a different common amount, and that's okay. So for example, if we have an axis like this, you could go 10, 20, 30, that's no problem. And then on this axis you could go the same distance, could be a different amount, like 2. But then this one has to be what? 4 and 6 and 8 and so on. So the jump for each sort of space has to be the same on the same axis, but they can be different from axis to axis. For example, the number of hours you work in a day is probably going to be somewhere less than 10, right? 0 to 10, maybe 0 to 12 if you have a long shift job. But the amount of money you make is going to be more than $10, right? So if you were to graph that point on a single graph, the number of hours would maybe be from 0 to 10, but the dollars you'd make would have to be 0 to 200 maybe. So do you know what I mean? You can't have 1 hour and then $1 all the time, because you have this little x-axis and you have this gigantic y-axis. So you can use different scaling for the different axes. And the plural for axis, do you know what plural is? Plural means more than one. So axis is singular, axis, is. The plural for axis is axes. So if I say axes, I'm not actually making a mistake or being lazy. Axes is multiple axes. Okay, we don't say axes, we say axes, just in case you're wondering. All right, label each axis with what the variables represent. So we talked about this the other day, didn't we? Last lesson, talked about this. So you want to have a also title, there it is, title the graph. So let's label each axis, okay? Label each axis, all the axes, with the variables, okay, with the variables. And I would also say you should have in bracket units as well, all right? Not on these notes, but add them to the notes, please. And that's because, you know what? I teach chemistry and physics and stuff in the grade 11 and 12, and when we do graphs there, you have to have your units on the graphs. So may as well practice now. May as well get used to that. There has to be a title on the graph. Okay, has to be a title. And the independent variable always goes on the x-axis. Super important. Independent variable goes on the x-axis. Dependent on the y-axis. So we always kind of like think about the x first. And in the coordinates, the x is written first. So we think about the x value first, and then we kind of measure the y value, or the y value responds to the x value. Okay? So independent, and maybe, I don't know if you guys are drawing this out with me, but this is going to be the independent variable. Independent. And then this is the dependent variable up here, okay, this y-axis. Okay, pause. Questions about this? Okay, you learned all this in grade 3, right? Not new? Okay, it's good. Good for us to be on the same page. All right, I'm gonna move on. Let's keep going. All right, again, I feel like we talked about a bunch of this yesterday. Here's where it comes officially, though. What is a linear relation? Remember we talked about linear? What's the root of the word linear? It is line, right? So in math and in English and in science, this is a very important skill for you to have. If you don't know what a word is, there's a couple important things. Look at the word in context, in the sentence, okay? That will give you a hint as to what this word means. The biggest thing, though, is you need to kind of break the word apart and see what the root of the word is. And that will give you a hint. When I read, I read all sorts of technical journals and things like that. I come across a word, I'm like, oh, I've never seen that word before. But if I look at it, it's got this part and it's got this part, and I'm kind of familiar with, you know, some of the Greek roots of words. And a word like linear, I'm like, linear, oh, I can't remember what that is. What's the root for linear? Line. Oh yeah, line, straight line. Okay, so this would be a relation that has that looks like a straight line. Okay, so you need to break words apart if you're unsure, because the smaller words that these words are built on, you'll probably know. Okay, all right. Linear relation, when the relationship between the independent and dependent variables can be represented in a straight line graph. So linear relation, hi. Yes, if you need to. A linear relation is a straight line graph. And this is really important. We talked about this yesterday. We uncovered this yesterday, but let's make it official. A constant change in one variable, produces a constant change in the other variable. And if you think back really to yesterday, 2 days ago maybe, in the lesson, when we talked about the table of values, remember the x, y? Remember we noticed that the y values always went up by the same amount. And the x values always went up by a consistent amount as well. And so that is your clue that you have a linear relation, because each jump in the independent variable represents a consistent jump in the dependent variable, linear. So this is a linear straight line relation, a consistent jump for both graphs, okay? Now, this one here is a solid line. This is a dashed line, or you could think about this as maybe separate points too. That's the slight difference here. Would you still call this some kind of linear relation, though, in the second one? You think that's linear? Yes, because it is line-like. It's a straight line. Now, do you know why some graphs might have a line that is connecting dots, and why some graphs would just have dots that are separate? Anybody know? There's a reason why we would do that. Anybody know? Okay. Yesterday, I was a little loose with this, but I want to be concrete. I want to be specific about it today. When we did the gym memberships, remember that? Okay, we connected those lines, right? I didn't mention it then. I didn't want to throw too much at you there, but it depends on if you get charged like per day. If you have a different amount that you would be charged every day, we would have good reason to connect that line, because halfway through the month you might owe halfway between the beginning of month and the end of the month, right? So if you owe $20 here and then $40 at the end of the month, well, if you only go for half the month, you would owe $30, right? But some gym memberships aren't normally like that. You pay for a whole month at a time. So if the value of what you owe in that case doesn't change within the month, then we probably wouldn't connect those points. Okay, let me think about it another way. If we're graphing our steps to home, okay, you're walking from school to home, it's probably okay for you to connect all the points of the distance you are from school. You know, when you measure every 15 seconds or whatever, you measure, okay, I'm 10 meters, okay, walk, 27 meters, okay, walk. It would probably be a good idea to connect the points, because that's a continuous function, okay? You are this distance at exactly this time. But if it's things like number of people, we probably wouldn't connect those dots, because we can't have half of a person or 0.7 of a person, right? It's like you have one person or you have two people. You can't have anywhere in between. So if we're graphing the number of people, you probably wouldn't connect the dots. You know what I mean? You have only whole people. If someone's missing a limb, it doesn't count. Okay, you're still a whole person. Okay, you can't say, oh, I'm only 0.9 of a person. I only have one arm. No. You're still a whole person. So does that help? If the points in between these dots are not reasonable, we wouldn't connect them. If the points in between the dots are reasonable, then we can connect it. Moving of temperature. There's always a temperature between temperature A and temperature B. There's always one in between there, so we could connect those dots. People, no, there's one here, then there's two, then there's three. Wouldn't connect them. Get it? Okay, so think about that next time, because I don't know if that's going to be a big deal in grade 9. Honestly, I don't know. But as you move through math, that's the thinking you want to think. Okay, this one, is this a straight line graph? Maybe it has a straight line portion to it. But then it does curve. So overall, this is not a linear relation, okay? This is not here. Not a linear relation. All right. Okay. So we talked about this last day, but let's get some more concrete practice, because we are now determining the linear relation, and we'll be able to also describe the equation by including both units. Okay. You should know how to do this. Let's try it. Let's make sure we got this going on. Now this is the independent variable right here. Independent variable. This is the dependent. So independent is always listed on the left, dependent on the right. This is like the x value. This is like the y value. Okay? We always check the y value. Okay? We check how much vertical change we have in the points. That's what we always check first, vertical change. So we simply find out what is the difference. We're not multiplying or dividing. We're just finding out what do we add to one point to get the next point that's listed. And so what do I have to add to 4 to get 6? I add 2. Very good. 6 to 8, I add 2. 8 to 10, I add 2, and so on. So this is good. This is good. We also have to check, though, if the x values are changing consistently as well. Then we know it's a linear relation. So what's happening here? This is plus 1. This is plus 1, and plus 1. Perfect. They're both moving consistently, so we have a linear relation here. Okay? That's how you know. How are these two related? Well, does this represent linear? The answer is yes for A. Yes, linear. how do we write an equation here? Okay, did this yesterday, last day. What we're going to do is we're going to take this difference, right, the 2 plus 2, and you multiply it by the x variable or the independent variable. So I'm going to go 2x. Okay, now you can just do this straight as long as this is 1. Can I just give you a hint though? When the questions get a little bit trickier, you're going to have to write 2 divided by whatever this change is. So it's going to have to be actually 2 over 1 times x. But because this is all 1, these are all changes of 1, you don't have to do that. But it's always this number divided by this number times this number. Okay, that's where you start. And that is the beginning of our equation to solve for the y of b. Oh, I shouldn't put x there. I'm going to put n, sorry, n. So it's 2n. So how do we get b? Well, we start off by doing 2 over 1 times n. That's 2 over 1 times n. And then as we did yesterday, we now start to check to see if we need to make any adjustments over here by adding or subtracting anything. So if I do 2 times 1, okay, 2 times 1, does that equal 4? Does that equal 4? No, 2 times 1 equals 2. So what adjustment would I have to make as far as adding or subtracting? I would? Plus 2. Okay, so plus 2. Now let's just see, before I set that in stone as my equation, let's make sure that works for the other ones. So 2 times 2 is 4. Would I have to add 2 to get 6? Yes. So it looks like that should work for all the points listed. 2 times 5 is 10, plus 2 is 12. Perfect. So I'm going to plus 2 here, and there we go. That's your equation. So b equals 2n plus 2. Questions about that? Thoughts about that? Remember that from the other day? Okay. Awesome. I'll do another one with you here. Let's do number 3. Let's skip over and do number 3. So I'm going to go a little quicker here. This is plus 1. Oh, it's not plus 1. Oh, 9 and 8. My bad. Look, we have to go down the list. So what should this be? Minus 1. Very good. Minus 1, minus 1, minus 1. Excellent. And this is plus 1, plus 1. Most of these are going to be plus 1 because they want to make it a little bit easier for you. So I'm going to go y equals, what do I do with this number again? I go negative 1 divided by positive 1 times what? Yeah. Negative 1 times x. That's where we start. Now I test my points to see if I have to make any adjustments. So negative 1 times 1, does that equal 9? Nope. What adjustments would I have to make, adding or subtracting, to get to 9 from negative 1? Plus, I have to plus 10. Yeah. So remember, here's 0, here's negative 1. I have to go 1 plus 9 to get to 9. So that's 10. All right, let's check a couple other points. Negative 1 times 3 is negative 3. What do I have to add to get to 7? Plus 10. That works. So I'm going to put plus 10 here. The last thing that I would do is I would erase the 1 as a coefficient. Don't leave it as a 1. Okay? And I would just have that negative x plus 10. So y equals negative x plus 10. Now, you can rewrite this as y equals 10 minus x. You could, of course, do that as well. You can switch around the terms that you're adding or subtracting, no problem. Just make sure the sign goes with the letter, okay? The sign goes with each term. It's a positive 10, so that's a positive 10 here. It's a minus x, that's a minus x there. All right, you guys do the last two on your own. See if you can do it. So number 2 and number 4 here. See if you can come up with equations for these table of values. Take a moment to do that. Okay, so I finished 2. I did not finish 4 yet. Okay, so let's first of all take a look at 2. I have a consistent sum here, right? That's the same, and so is this linear. I do 3 over 1 times h equals c. The adjustments that I would have to make, if I tried that out, 3 times 1 is 3. I would have to subtract 2 to get 1, and that works for all of these here. Okay, so that's my equation for my linear relation for number 2. Everybody get that? Everybody get that? Yes? Awesome, very good. Okay, number 4. Now, why didn't I finish number 4? Any ideas? Because it's not linear. Why is it not linear? Okay, because remember, what we need to see is we need to see on the right, we need to see a consistent pattern with a consistent pattern over here too. This one's good, but this is not a consistent pattern. Okay, it jumps up. So that's not a linear relation. Okay, those points are going to go like, so here's going to be 2, and then 5, and then 10, and then 17, and then 26. Like, it's kind of like, you know, it's a bit rocky. It's curved up, you see? So that doesn't work very well. That's not a linear. So you could just say not linear relation. Okay? Hope everybody sees that. This is critical right here. And if this changes in value, generally it's not a very good sign. Okay? And I think in all of these examples you're going to want to look for a constant change here with a constant change here. That's what you're looking for. Now, it is possible that only certain points on a line could be listed in the table, and it might look like it's not linear, but I think when we're learning about this now, they're going to give you regular points at regular intervals so that you can easily see this. And I'll maybe expand on that a little bit later. Okay, let's change gears a little bit here. And let's talk about this right here. This is going to be, we're going to be filling in the table of values here now, okay? We fill in the table of values. We're given the equation, and we're going to fill in the table of values. So for A, what we have to do is we have to use our independent or our input variable. Did you know it's also called the input variable, the x? That's the input. And that's what you put into kind of what's called this, you know, the equation machine here. And so we put the input in, and then we allow the machine to kind of do its work on it, and then it spits out the y value. So it spits out the dependent variable. So let's try that. Well, I don't know what y is, but I do know what x is. So I'm going to just insert 1 in for the x there. And now I have a solid description here of what y is. So y is unknown, but when I figure this out, I will know what it is. 2 times 1 is 2, plus 1 is 3. So you put a 3 right there. All right, so we go ahead and we do the same thing for the other x values. So 2 times 2 is 4, plus 1 is 5. You put a 5 there. 2 times 3 is 6, plus 1 is 7. You put a 7 there. And you can kind of see that there's a pattern emerging, right? And yes, this is plus 2. This is plus 2. So guess what this one's going to be? 9. 2 times 4 is 8, plus 1 is 9. This one's going to be 11. Okay? All right, let's do B real quickly to conclude our lesson here today. So y equals 10 minus, what's the input variable I'm going to focus on first? 1. So y equals 9. Good. What's 10 minus 2? 8. 10 minus 3, 7. And you see this pattern emerging, minus 1, minus 1. So this is going to be 6. This is going to be 5. Okay, very good. All right, that's where we'll end our lesson today. We're out of time. We will pick this up tomorrow and finish our 4.2 lesson.